Organic ions exhibit also resonance. Resonance of organic ions induces stability to them. Let's take an example, the carboxylate ion. The carboxylate ion is the conjugate base of carboxylic acids. Let's see that. This is the general structure of carboxylic acids. Carboxylic acids, as the name suggests, are acidic, and they're acidic because that hydrogen can be removed, so therefore they are proton donors. If they behave as acids, they produce the conjugate base of them, which is the carboxylate ion. So that's the structure of the general carboxylate ion, and R is only an example or a general representation of an organic group such as alkyl or aryl groups. Now, the carboxylate ion must be stable for carboxylic acids to be acidic, and carboxylate ions are actually stabilized by resonance. In other words, it is possible to draw another Lewis structure for this carboxylate ion. So let's try to do that, and this time we use this concept or this notion of Cayley arrows to indicate electron movement. Now, in the new Lewis structure, okay, the double bond should be between this negatively charged oxygen, okay, and that carbon. So therefore, if we move one of these lone pairs, and if we use a Cayley arrow, and it's a doubly headed arrow if you like, we need to take that arrow from that oxygen, and we take it to the middle of this oxygen carbon double bond. If you look at the origin of this arrow, it's actually from the negatively charged oxygen, and it's going to the middle of the OC bond, indicative of formation of a double bond between oxygen and carbon. But that will not be acceptable because carbon cannot be surrounded by 10 electrons. It has 8 electrons so far, and it's not according to valence or valency rules, okay, for carbon to have more than 8. It's in period 2, so it must satisfy the octet. Now, for that, we need to simultaneously break the carbon-oxygen double bond, releasing electrons on oxygen. So something like that with the use of Cayley arrows will be reasonable. Now, this means that this arrow means 2 electrons from this negatively charged oxygen have now been used to make a double bond between this oxygen and that carbon. The pi bond between this carbon and that oxygen has now been broken, and the 2 electrons have now been released, and they should now be placed on oxygen. It's resonance, so we need to use the resonance arrow, and now we can draw the new Lewis structure. So something like that is representative of the second Lewis structure or the resonance structure of the carboxylate ion. So therefore, the carboxylate ion is stabilized by resonance. The conjugate base of carboxylic acid is stable because of this resonance stabilization, and that's exactly why carboxylic acids are acidic to start with. If you recall your organic background, our organic background, we will remember that the pKa of this hydrogen is about 5. So it is actually acidic. That's because the carboxylate ion is stabilized by resonance.